We're going to look at page 558, number 13. The question is about commercial movie releases. This question is quite involved. We have to do many things here. First, it says for each exercise, find the equation of the regression line and find the y prime value for the specified x value. Remember that no regression should be done when r is not significant. So first we have to determine whether or not r is significant. We do so by running a test. For the sake of time, I'm going to give you r. R is 0.880. So we're going to go through our steps. Step 1 is to write our hypotheses. We have HO, our null hypothesis, being rho equal to 0, and our alternative hypothesis being rho not equal to 0. The rho is spelled R-H-O, but it's pronounced rho. It does look like a P here in red. The way that we can distinguish the difference between a P and a rho is that there's a point on top of the P, and also it's a little bit to the right. The rho is a little bit to the right, where the P is more vertical, straight up and down. For our hypotheses, you don't have to identify the claim, since the question will always be whether there is a significant linear relationship between the variables. For step 2, we're going to find the critical values. Our alpha is going to be 0.05. And the degrees of freedom is going to be n minus 2. In this case, n is equal to 9. So it would be 9 minus 2. Our degrees of freedom will be 7. Because our alternative hypothesis is not equal, this is going to be a two-tailed test. We're going to use table F to find the critical values. It's two-tailed at 0.05. So go 0.05 with the degrees of freedom of 7, and you find their intersection, which is going to be 2.365. Because it's two-tailed, we have two critical values. I'm going to abbreviate critical values with CV. It's going to be plus 2.365 and minus 2.365. For step 3, we're going to compute the test value. Our formula is T equals R times the square root of n minus 2 divided by 1 minus R squared. Which is equal to 0.880 times the square root of 9 minus 2 over 1 minus 0.880 squared. And you'll come out to a test statistic of 4.9. I know your favorite question is, will we be given this formula on the test? Yes, you will be given this formula for the test value on your test. We'll do steps 4 and 5 together in one step. We're going to make a decision and then summarize our results. We're going to draw a curve with our test statistics, with our critical values. So our critical value of 2.365 and at negative 2.365. If the test value lies within this region, these shaded regions, then we are going to reject our null hypothesis. 4.9 is over here. So we are going to reject our null hypothesis. That's our decision for step 4. Step 5, we are going to summarize the results. Reject HO. There is a significant relationship between the number of releases and the gross receipts. Our R value was 0.880. Remember, on the number line, the closer it gets to 1 or negative 1, the stronger it is. 0.880 is right here. So you know this is going to be a positive strong linear relationship. So now that we determined that there is a significant relationship between the two variables, now we can find the regression line. We're going to make our 5 columns. Let's do it in black. The number of releases, which are the x variable, the gross receipts, which is the y variable. We have xy, x squared, and y squared. Let's go ahead and write our numbers for each column. I need a little more space, so I'm going to abbreviate receipts. So we need this table in order to find our A and our B for our regression line. So in order to find the A, we multiply the sum of the y's, 9,283, times the sum of the x's squared, which is 299,315, minus the sum of the x's, 1045, times the sum of the x times y, which is the 2,380,435. Divided by our sample size is 9 times the sum of the x's squared, 299,315, minus the sum of the x's, which is 1045 squared. Put this into your calculator and you'll get A is equal to 181.661. Again, you guys will be able to be given this equation for A, so you don't have to memorize it. For B is our sample size 9 times the sum of the xy's, so 2,380,435, minus the sum of the x's, 1045, times the sum of the y's, 9,283, divided by the same denominator in A, which was 9 times 299,315 minus 1045 squared. Put that into your calculator, you get B equals 7.319. So putting the A and B together, you have y prime equals 181.661 plus 7.319x. So it's always in the form y hat or y prime. In this case, we can do, let's change it to the prime. Y prime equals A plus bx. The question says find y prime when x equals 200 new releases. So this here is our regression line. Equation for the regression line. Regression line equation, we'll call it. So to find y hat when x equals 200, we're going to substitute 200 in for x. when you put that into your calculator, you'll get y prime is equal to 1,645.5. Remember, these are in millions of dollars. So we'll put million